Assalamu alaikum. Myself, Dr. Ansari Farzana with Zama, Department of Chemistry, J.T. Arts, Science and Commerce College, Malegaon. Welcome all of you. Today we will continue the column chromatography, and in the previous section we have seen experimental technique of ion exchange chromatography. In that we have seen preparation of column for ion exchange chromatography. Today we will discuss method of separation. The column is filled with an ion exchange resin and mixture in the form of solution is poured into the resin and is allowed to percolate through it. Then the eluent, that is the second solvent, is allowed to percolate. The exchange process takes place in this, which is shown in this reaction. RH plus M plus is equal to Rm plus H minus. M plus is the ion from the solution and it is exchanged with H plus of resin. In the same way, RNH3OH minus plus A minus. A minus is from the solution and which is exchanged into the solution as RNH3 plus and A minus, and OH of the resin is released. Due to difference in ability of resin to exchange the ion, separation of ion takes place on the resin. Some ions are exchanged quickly, they remain on the top of the column, and some ions which are exchanged later come down and remain somewhere below the top one on the column. Thus, there is a stepwise exchange of ion between the resin and the component of the mixture, which is shown in this figure. The figure shows the separation of transition metal on the resin. Now, what is meant by elution? Process of removing exchange resin by washing solution is known as elution. The solution used for elution is known as eluent, and the solution coming out from the column is called as eluate. The eluent generally contains a complexing agent which form a complex with ion displaced. Each ion can be displaced by different eluting agent which contains different complexing agent. The complexing agent is then removed by a suitable method and ion is recovered. There are various applications of ion exchange resin or ion exchange chromatography. Ion exchange chromatography find numerous applications in separation science. It can be used for laboratory separation, purification of water, extraction of metal, treatment of expensive pharmaceutical derivatives, etc. The two main applications of ion exchange chromatography are separation of metal ion and non-metal ion on an anion exchange resin column and purification of water. Separation of first Separation of metal ion and non-metal ion on an anion exchange resin column. Separation of, for example, separation of zinc and magnesium ion on anion exchange resin. Several metal ion like iron, aluminium, zinc, cobalt, manganese, etc. can be absorbed from HCl solution on anion exchange resin due to formation of negatively charged chlorocomplexes. Each metal ion has a well-defined pH range over which it is absorbed from HCl solution. This forms the basis of separation of metal ions. zinc is absorbed from 2 molar HCl solution while magnesium is not absorbed. The zinc and magnesium are separated from each other by passing through anion exchange resin. Zinc can be eluted from column with dilute nitric acid. A column of anion exchange resin is prepared with 15 gram of diolite A113 in chloride form using 2 molar HCl. The standard solution of zinc and magnesium are prepared by dissolving accurately weighed quantity of zinc and magnesium in HCl and diluting each to volume of 250 ml in separate graduated flasks. 10 ml each of zinc ion and magnesium ion solution are pipetted out into a small separating funnel supported on the top of ion exchange column. This ensures the mixing of two solutions before entering the ion exchange column. The mixed solution of zinc and magnesium is allowed to flow through the column at a rate of 5 ml per minute. The funnel and the column are washed with 2 molar HCl and the liquid level is not allowed to fall below the top of the resin. All the effluent containing magnesium is collected in conical flasks. After collection of magnesium, the receiver is changed and zinc is eluted with 30 ml water followed by 80 ml of 0.25 molar HNO3. Magnesium and zinc in the respective flasks are determined by neutralization with NaOH followed by titration with standard EDTA using a solution of buffer pH of 10 and solochrome black tea as an indicator. Commonly, the most nonpolar solvent is used for introducing the mixture of component on the column and also as the first solvent for development of chromatogram. Due to this, initial adsorption of component on the column takes place rapidly and if necessary, the further development of the chromatogram may be accelerated by the increasing polarity of eluting solvent. The solvents used for elution have sufficiently low boiling point to ensure rapid recovery of the eluted components. The series in which eluting solvents are used in increasing order of polarity is called Allotropic Series. The allotropic series comprises of hexane, cyclohexane, carbon tetrachloride, trichloroethylene, toluene, dichloromethane, chloroform, diethyl ether, etc. In practice, rather than changing the solvent system abruptly, the composition is gradually changes by increasing the concentration of more polar solvent. This may be achieved by using successively mixture of non-polar and polar solvent in which proportion of the component are in the ratio 90 as to 10, 70 as to 30, 50 as to 50, 30 as to 70, 10 as to 90 and so on. The order in which the components of mixture are eluted depends on their polarity. For example, if a mixture of two components differing in their polarity like hydrocarbon and ketone needs to be separated, the more polar ketone will be adsorbed more strongly than adsorbent and hence the hydrocarbon may be eluted with relatively non-ketone is then eluted by using more polar solvent. The ease of elution of adsorbate may be broadly in the following order. Saturated hydrocarbon is greater than alkenes, alkynes, aromatic. Hydrocarbons is greater than ester, aldehyde and ketone is greater than amine, alcohol, is greater than phenol carboxylic acid. Now we will continue the chromatography in the next video. तब तक के लिए अल्लाह हाफिज़. Thank you.